Hello, welcome once again on our webinar, on our meeting. Thank you very much for every message that you sent us using all our channels, Facebook, YouTube, email. You are asking for many things according to the gas installation system, according to STAG products. And with most frequently asked question that we have from you is our questions about the timing processor, our
yes,
tab.
Yes, exactly. Just the last period, many questions was related with TAP unit.
Yes.
That's why we decided to extend some information and some rules instead of the last one.
Mm-hmm.
And today we're gonna focus on TAP 03 on version on 01, and 01 means that it's dedicated for the inductive sensors of the crankshaft position.
That's right. We prepared the car. We have the car in our workshop, and we're gonna connect some devices. What I want to say is oscilloscope, and gather the signals. We will show you what are the typical signals in the car that have the inductive crankshaft position sensor. We also want to connect to camshaft position sensor, and we will show you how to locate the signals and the wires, right.
And so on. The next step we will show you the calibration and the base settings of the tap.
That's right. But the main question is why we need or want to use tap.
Yes,
in the gas installation.
The genesis of the tap installation in the system, in the engine. So we have the graph, and on the graph we'll try to clarify something. Okay, let's go on. On the left side there is a typical graph in relation to the piston position in cylinder, and here we have information in relation to the position of the crankshaft in the engine. This is the top dead center position when the piston is on the highest level in the cylinder. This is the pressure in the cylinder, inductive pressure, and the point of ignition. So normally when the petrol engine is designed to work with petrol, it has built in the map in relation to the ignition advancing, yes, or retarding. In case we change the fuel from the petrol to CNG or from the petrol to LPG, there is a chemical differences between these fuels, and the main reason that we need to change something in ignition in the engine is that if engine is prepared to work with the petrol, the ignition angle, for an example, in these conditions like is 10 degrees. There's an example. If we start burning the mixture 10 degrees before TDC, the pressure is rising up, and then the maximum point of the pressure it's around 10 degrees after TDC. If we change the fuel type, because for an example LPG or CNG is burning a longer time, the reaching of the time of the highest pressure in the cylinder, it's also moved another 10 or 12 degrees more after TDC. So the end effect of this was happening here is that we are losing efficiency of the engine, and all fuel efficiency, the torque and the power can be much more lower comparing to the petrol. So to handle it properly, we should advance the ignition angle more. In case of LPG is 7, even 8 degrees. In case of CNG fuel, because it's more lazy than petrol and more lazy than LPG, using a lazy word, we should advance even 15 degrees more than this, to have similar point of highest pressure in cylinder after TDC. That's why this is very important and this is crucial. So to reach proper efficiency, we need to advanced ignition comparing to the petrol data. Yes? In some engines with very reboiled and very advanced algorithm and NOx sensors, the petrol ECU can advance a few degrees comparing to the petrol walking. Then if ECU realized that there is a possibility to advance ignition, he's doing himself this acceleration, yes, of advancing the ignition angle. But this is a very rare situation, like 8 to 10% of the cars has so advanced ECU that can handle automatically advance the ignition. All other cases, we need to do it using a TAP unit. And this is the genesis of efficiency of the engine, how to have it better, just install the TAP system to engine steering system. So we have, as we said, car. The car is Audi A4 with 1.8 turbo engine. It's equipped with inductive crankshaft sensor and the halotronic camshaft sensor. So the next step, we'll start the engine, we'll connect the oscilloscope, show you how the signals look like, and so on, step by step. We'll try to figure out and explain you everything.
Okay, we have already engine running, and here in the compartment of the engine we have several sensors. What are interested are two sensors. First of all,
first we have the crankshaft sensor, camshaft sensor, and it's equipped with the 3 wires. We already checked that on these wirings, one is the ground, second is the power supply, and the third one is the signal. So we will connect the oscilloscope probe to signal sensor.
Okay.
Then next we're gonna have here the crankshaft signal socket, and we already checked that one is the ground wire and there is 2 signal wires, and we will connect first on this wire the oscilloscope and show you the screen how the signal looks like for the sensor. Okay. So we ask you to show the screen. Okay, Thomas, comment the blue.
Yes, the blue probe. We have connected the blue probe to the crankshaft position sensor. Camshaft position sensor. Sorry. As you can see on the oscilloscope on that graph, this is the typical signal from the halotron sensor.
Exactly.
So that means that we can connect tap 03 to that sensor to gather the information about the position of camshaft. This particular engine, this specific engine, has 1 sensor. If we have a car with 2 sensors, we can also connect our tap. You can see it on the manual that the tap has the possibility to connect to 2 camshaft position sensors. Okay. Yeah. So right now we have the signal from the camshaft position sensor, and to be sure that we chose the proper TAP device, we also connected the yellow probe to the crankshaft position sensor.
Yeah,
so
let's turn on the signal.
Yes, we turn on the signal from the channel number 1. I will change the time division. Maybe once again.
Oh, it looks perfect.
Okay, so in the yellow probe, as you can see, we have the typical inductive signal with the type of the signal.
Yes, it's
rising
up. The gap, as you see here on the yellow graph, goes by the 0. It's rising up.
It's rising up. So, according to the manual, the S diagram, wiring diagram from our software, just to remind you, when you have our AC STAG software running, you can go to help and then to documentation, and you will have access to all our manuals. So when you open the manual for STAG TAP 031, as you can see on this yellow graph, there are two situations.
Yeah.
We have this crankshaft position sensor that have three cables, the ground, the shield one, and the two signals. As you can see, on the
we need to choose where to connect the yellow-white pair.
That's right.
And where to connect the green-brown pair.
That's right. That's right. So let's say we have the A and the B cable. So example 1 and example 2. So right now we're gonna connect the oscilloscope to the A cable.
Exactly.
And then to the B cable, just to be sure that
confirm that the gap on the signal in situation when the signal goes across the 0 is going down, or is going rising up. Yes.
That's it. That's edge rising and falling. Right?
Exactly. And as you already saw, show the oscilloscope please again. Now we have the rising situation.
That means if you have the rising situation, that means according to the manual and the wiring
we
diagram,
should be on wire A with the yellow-white pair of the cable.
That's right. Now, just to confirm, we're gonna connect oscilloscope to the B.
Exactly.
signal.
I will switch the sensor to B. What happened?
I will turn off the channel 2 just not to get disturbed. Okay.
Exactly. The situation is right now clear. The signal is now falling down across the 0. Yes.
That's right. So we have just confirmation that on the second wire, according to this diagram, we have the example 2, the H falling. So tap should be connected with the green and the brown yellow to that wire that is called B, right?
Exactly.
Here.
That's the point.
Okay, so we have the proper cables, so we can connect our timing advanced processor to that cables. Maybe some information that's on the right side, because we have also questions about the connection
of the brown and the gray, the wires that they are necessary or not. And we are telling you now that the map or ignition coil, it's not necessary to start the process of calibration and the process of overall of tap working. Yes, this is like an option. Ignition coil or map, they are just if they are connected, we can use additional functionalities of the TAP.
Yes.
So it's not a demand. Yes.
It's not a demand. That's right. That's right. Marcin mentioned that we can use some advanced function. One of that advanced function is auto adaptation, because our TAP has also the function of the auto adaptation, just like our gas controllers. So we can also use the auto adaptation mode, but to use it, you need to connect all the wires according to the wiring diagram.
Like in manual.
Like in manual. That's right. That's right. So, if you have if we have all the signals checked, we can connect TAP.
Yes.
Okay.
And then we can start the process of auto calibration and settings.
That's right. Right now, we open the AC STAG software, as you can see on the screen. This equipment right now has the factory settings, so that's right. That's why you can have the information about the synchronization of the crankshaft, the camshaft sensor.
Yes,
because
this is a typical communicate after starting the TAP.
That's right. After the first connection, don't worry that on the right side the only two or three values are present: the internal temperature and the battery, because the main information just after the connection of the TAP. When you start the auto calibration, and the system will start to read sensors, the information will appear just right on the right side in the monitor window.
Exactly.
As you can see, we do not have also the RPM signal, but we will gonna have the readings after
auto calibration.
after auto calibration. So
at the beginning, we should choose fuel type that will allow us to set the next step.
That's right. That's right. As you can see, when you look at the software, that the hardware of the TAP just came from the factory. Some of the functions are on the gray. We cannot check it or choose or change it because we didn't start the auto calibration. So maybe we can start it. Okay.
Exactly.
We have two possibilities. We can start the fast calibration or the standard one. Normally we are using the standard one calibration, but it takes a little bit longer time,
yes,
and you need to
if
press
you just analyze all the signals, even they are not connected, they will happening step by step. So it's an extended version. It will take 4 or 5 minutes. Now we're gonna go with the fast one to just spare your time.
That's right. So I checked that we gonna use the fast calibration, and we gonna start calibration. Okay, the information also always appears to just not to change the load of the engine during the auto calibration, and the beginning of the process. It will take some few seconds. Right now the system is analyzing what is happening and reading some information from the sensors.
And one advice, during the auto calibration, if you will see that it's stuck for a few seconds, sometimes rise up the RPM using the throttle position. Just for a few seconds, for 5 or 10 seconds, you can rise up the idle gear to 1000, and then if it will accelerate, release the throttle, leave it on idle, and let the finish normally on idle.
Okay, so right now, as you
yes, calibration is finished.
Yes.
See the effect.
This is the result of the auto calibration. So CR is crankshaft position sensor signal. So as you can see, the tap understand the signal. We can see. We can tell from
similar like on oscilloscope.
On oscilloscope.
Screen.
That's right. And the CM1 is camshaft position sensor number 1. Is also the typical halotron signal, just as you can saw on the oscilloscope. Exactly. Connected to the directly to the sensors, to the wires, right? So tap is working well right now. As you can see, there is no errors here because the synchronization is fine. Right now what you need to do is set.
Yes,
to
choose the map. For an example, we are offering you the simplest method is going to use the map. So we will go to the type, choose the map, then you get 3 different maps. First is 2-dimension absolute, and this is the simplest method of use the 2-dimension absolute. You just can go follow to the this map, choose this first map, put the regulation points like in Qbox on QNext or Qmax ECU, like in multiple line. Then after idle, you put the first point, second point just close to like 1200 RPM, and then using arrow you can go up it means that we are advancing, or you can go down and you are going to retarding the ignition. And you can retard ignition also using tap to retard ignition if you are converting the engine from CNG to LPG, for an example, because the CNG default advanced ignition map will be just too high for working on LPG. That's why you can use tap to also retard the ignition. Normally, if we're going LPG, we should go, as application shows us, maximum 5 degrees. This is a recommendation. In some engines you can go even 7 degrees, and it's also still good value to handle proper performance and efficiency. And as you see here, this is simplified map, and it also helps to finish the settings and have good, much more better efficiency of the engine after setting the tap to the engine.
That's right. We also recommend if you want to adjust the tap on the road, we recommend also connect gas controller
Exactly.
to the PC just to check the correct information from the gas controller, because it's often happened that if you change the angle, if you change the ignition angle, you can have the mixture too rich when the car is working on LPG or CNG.
Yes, just we are reaching a better efficiency of the burning the mixture in the engine cylinder. That's why end results of advancing is that the mixture is going just B2B too rich. And at the end, you will want to check some settings if you are meeting some engines with variable cams, 1 or 2 cams. These options can help you to prevent some jerking situations, so you can turn on cam correction or fast correction, and this correction helps you in situation when you will see on the graph that during acceleration camshaft is going minus to plus. This is a situation when variable timings occurs, and during this, if you meet some issues with the jerkings, you can turn on these corrections. You can change the strategy of these corrections, reduced or advanced a little bit the algorithm of correction to have a smoother end effect of the driving conditions.
That's right. Sometimes after auto calibration, when you have the readings from in the monitor on the right side, you can see that sometimes the RPM doesn't match the RPM on the dashboard. Usually you can have the value 2 times higher, 3 times higher than it's originally in the car. You can check it for example in the OBD reader if you have the gas controller connected to OBD. If after auto calibration the value of the RPM is too high, you can use the RPM divisor just to change to 2 or 3, start the auto calibration once again, and then you will have the reading of the RPM on the right side with correct values, just the same like on the dashboard in the car or in the OBD reader.
Exactly.
Okay, you could also after you set everything, you need to change also the map sensor, the engine load sensor. That's why it's not present right here. You don't have the timing advance present, because you need to also calibrate the
load
sensors.
sensors.
The
yes.
load
it's
sensor.
needed, of course. If you want to use a different maps comparing to the 2-dimension absolute. If you want a 3-dimension, so you can build the map according to the load sensor, and you can use the load sensor, the map sensor, or the throttle position sensor. It just lay on your choice.
That's right. If you want to use the sensor that Marcin mentioned, just remember to start the full auto calibration, not just only fast calibration, but the standard one. Full auto calibration, it takes longer time, but TAP will read all the sensors connected to the TAP.
Exactly. In case of another questions will arrive, do not hesitate to write down or call or use the social media to connect with us. Next webinar will be related to TAP 0302 version. It's dedicated to the Holotronic digital sensors. There's going to be on different car with different settings. Thank you for your attention. Please do not hesitate to contact us and take care.
Thank you very much. See you next time.
Bye.